Inheritance is one of the most important concepts in object-oriented programming. Now, it really deals with the capability of a class to derive properties and characteristics from another class. It drastically reduces the code redundancy as it allows us to use the derived class to inherit all the properties of a base class. Now, the base class is also known as a superclass or a parent class, and it is responsible for sharing its properties with the derived or child classes. And the derived class is also known as a subclass or child class, and its responsibility is to inherit some or all of the properties in the base class. Now, we looked at some access specifiers before. We looked at the public and the private access specifiers. And now let's take a look at the protected. Now, class members declared as protected can be used only by the following. Member function of the class that originally declared these members, or friends of the class that originally declared these members. It may be used by classes with derived public or protected access from the class that originally declared these members, and also direct privately derived classes that also have private access to protected members. Now I've added a few keywords to note. So we've looked at the class keyword, the private and the public. We've looked at the scope resolution operator, and now I've added the protected keyword and also the syntax that shows us how to use or how to do inheritance in C++. So if I wanted to create a child class or a derived class called bus, and I wanted to inherit from our vehicle class that we've been working on, this would be the syntax that would allow us to do that. So we simply declare a class of bus, and then we use our colon. Then after the colon, we say public to ensure that the vehicle class is publicly accessible to the bus class. And then we just open up our curly braces and define our logic inside there. So let's continue on our example and see how we can implement this. Now back in our example, let us continue what we were building with the vehicle class, and let us now add a child class and let us define it as bus. So we're going to inherit all the attributes of vehicle in our derived bus class. So a quick and dirty way to just quickly show and demonstrate inheritance here. I'm just going to stay inside the vehicle.h file, and I could create a new class like we did for vehicle by adding a new class. But just to quickly demonstrate, let me just define my new class right here below the vehicle class, and of course use my colon, and then declare public vehicle. Open up my curly braces, and this is now our child class of bus. So currently we are inheriting pretty much everything that is inside of our parent class. So if we define an object from bus at this point, so let's go back to our main. So if we were to define an object for bus, let's just call it bus1. And let's say we don't do anything else but just create the instance of the object. And if we run our program, we'll see here that the default constructor in our vehicle class has actually executed. Right? So if we go back and check our vehicle constructor, our default constructor simply prints out a statement that says performs some action, and this gets triggered as soon as we create an instance of our bus class. Okay, so right away we can see inheritance is already working in our child class. Now one thing I want to demonstrate here in our child class is the concept of constructor inheritance. So not only can our child class inherit all the different attributes and methods, etc., data members from our parent class, but we can also define a constructor in bus that inherits from our parameterized constructor in vehicle. So let me show you how that would be done. So let's first let us specify a public access. So we're going to say bus, open our parentheses, and we're pretty much going to put the same data members. So we're going to do a double for the weight. Let's do a string t, and that's it. So the same way we use the colon to inherit from our parent class, we can use a colon here to inherit the constructor from our parent class. So we can inherit our vehicle constructor, and we are just going to list the variables that we are going to inherit the values from, which would be wheels, W for weight, and T for type. And we just open and close our parentheses and end with a semicolon. So right here, this is known as constructor inheritance. So now, back in our int main, you see we are now getting an error. And the reason for this is because our object is now expecting us to put in the values for wheels, weight, and string. And if you pay attention here, it also says there's no default constructor for class bus. So if we didn't want to necessarily define any values as soon as we instantiate our class, we could create an empty constructor like that, which would be our default constructor, of course. So this lets our program know that, let's spell this correctly, F-A-U-L-T. So this lets our program know that, okay, we have two constructors. We have overloaded our constructor. We have an empty default constructor, and we now have a parameterized constructor that inherits from our parent class. So in our default constructor, I could perform a default action. So let us say this triggers default bus action. And another semicolon here. Let's remove that. So now if we run our program again without doing anything else, now our child class constructor should fire. Well, yes, right. So both of them fire at this point. So it performs some action, which is the parent class constructor, and it also triggers its own default bus action. So we have both the parent class and the child class constructors, which get triggered upon the creation of this child class. So since we have created a constructor that inherits from our parent class, let us demonstrate how that would work. So the same way we did before, the first value would be, let us say our bus has 8 wheels and the weight is, let's say, 3,500 kilograms. And let's say this is a coaster. Right, so now we can call our object and call our method rather to print the vehicle info, and that would print the information that we just defined here. So let's run our program. Right, so it lets us know the vehicle has 8 wheels. It's 3500.21 kilo, and it is a coaster, and it is also not a hybrid. Okay, so everything is working as it should. And of course, if we wanted to call the set vehicle info, we could also do that by entering those values here. All right, so that should basically give you an idea of how inheritance works. Let me remove this for now. Let us just leave it as it is. So one last thing I wanted to show you, one quick thing. So if I actually wanted to define a custom method, so let's say the return type is void, and I just want to define my own print function. Let's call it print for now. We're going to expand in the next video and demonstrate polymorphism, but for right now, let's just define a simple print function. Let's say I wanted to just do a print of, so I have to std cout. Let's say I wanted to print the number of wheels. So you can see that the IntelliSense is not helping us out with that, and we are getting an error here. So even though we are inheriting from our parent class vehicle, we do not currently have access to the variable number of wheels. We're getting an error here, and it says number of wheels is inaccessible. So the reason for this is because our data members up here are still private. So remember, if the data members are private, they can only be accessed within the class scope, which would be this beginning curly brace to this closing curly brace. So anything outside of this class body is outside the scope. So if they are private, nothing outside would be able to access it. So we just looked at the definition for protected. So what we would need to do is define the protected access specifier. And we can see the error message has now disappeared from here. And if we wanted to call bus 1, let's just change this to print and run our program, we would be able to successfully print the number of wheels. The term polymorphism is the combination of poly and morph, which means many forms. So in object-oriented programming, we use 3 main concepts: inheritance, encapsulation, and polymorphism. And it is really a feature of OOP that allows the object to behave differently in different conditions. So we have 2 types of polymorphism. First, we have compiletime polymorphism, and this occurs when the compiler selects the appropriate function at the compile time. And this is achieved by function overloading and operator overloading. Secondly, we have runtime polymorphism, and this is also known as dynamic or late binding, and it's achieved when the object's method is invoked at the runtime instead of at compile time. So we see here function overriding and the use of pointers are how we achieve runtime polymorphism. First, let's take a look at compile time polymorphism, and we will demonstrate this using overloaded functions. So we're going to declare a simple class. So let us create a new class. We can click on our header file, add a new class. And this class name, let's call it calculator. And now inside my calculator, let me define my access specifiers. Let's do private first, and public. What I'm going to do is define two functions called sum, and then I'm going to overload it. So we've already seen this concept in our vehicle class where we overloaded. So let's take a quick look at our vehicle class again. So we're here where we have overloaded our vehicle constructor. This is a prime example of function overloading. However, let's create a new example. So I'm going to call this int sum, and I'm going to pass in two variables or parameters, x and y, and I am going to return x plus y. So that's it. That's my sum function. So to overload this sum function, I am going to declare another sum function, and I like to use uppercase for my function name. So let me change this. And we're going to pass in x, y, and z. And we're going to return the sum of all three. So here you see we have defined two functions, both with the same name. However, they have different return types, and they also have a different number of parameters. Okay, so this is an example of overloading a function. So back in our main file, we have to include our calculator. So let us include it, and let's instantiate our calculator. So let's say calculator, and let's just call this obj. So I'm going to print out both instances. So first, let's find the sum of two numbers. Let's do equals. And I'm going to call object dot sum, and let me pass in 15 and 30. And I'm going to do the sum of three numbers is equal to the very same object, and this time we're going to pass in several doubles. Let's throw in an end line also. All right, so let us run our program. Right, so you see that our sum function has returned the sum of two numbers, which are integers, and also the sum of three numbers, which are of type double. So this is a very basic example of how we would overload a function at compile time. We've already taken a look at function overloading, and now it's time to explore the concept of operator overloading. So operator overloading is a compile-time polymorphism in which the operator is overloaded to provide a special meaning to a user-defined type. So it is used to redefine most of the operators available in C++, and you will usually see operator overloading with arithmetic operands. So only existing operators can be overloaded and the new operators cannot. The overloaded operators contain at least one operand of a user-defined type, and like with any other function, an overloaded operator has a return type and a parameter list. So the second type of compile-time polymorphism that we have is overloading an operator. So now let's do a quick and easy example of that. So first, let me actually define a variable. I'm going to call this num. And down here, let me just put a comment. So right here, we have done function overloading. And now we are going to be doing operator overloading. Fine. So what I am going to do is I am going to overload the unary operator plus plus. So unary operator. And as we know, this increments by 1. Okay, so I'm going to create a new definition of this operator, overload it, and have it increment by 5. So before I do that, I want to, let me declare a constructor here. So calculator, and what my constructor is going to do, it is just going to give num a value. So let us give num the value of 10 and close it off. So this is my constructor. So now that num has a value of 10, let me redefine my unary operator. So let me call it void, and then operator will be plus plus, and I am not going to pass in any parameters, and this function is simply going to say num plus equals 5, and this is the same as writing num is equal to num plus 2. All right, so this is just a shorthand method to achieve that. Let me define another function here, and what this function is going to do is allow me to print the value of num. So print num, and let's just say cout the value of num is equal to, and let's just put num. Okay, so let's see what this error message is saying. All right, so it's gone. So now back in our int main, let us test this out. And what I'll do, first I'm going to create a new object. So let's say calculator, and let's call our object cal. All right, short for calculator. And I'll comment out these 2 lines for the time being. And a shorthand method, if you're using Visual Studio to comment out a portion of code that you have highlighted, is you hold down the Control button or key, and then you press K, then C. and you see it will comment out that block of code that you have highlighted. To uncomment the same block of code, you hold down on the control key, press K, then U. So those are two pretty useful keyboard shortcuts. So first, now that I have created my calculator object, let me call my unary operator that has been overloaded and apply it to my object. So what we have done here, we have called our void operator function, and now let's do cal.print so remember the current value of num is 10, and we have defined overloaded our operator to increment by 5. So let us run this and ensure that that is what is happening. Okay, so we have some errors, so let us see what this is saying. This is saying undeclared identifier. Okay, so what we need here is our std : okay, so remember I could put a using statement here at the beginning of my class and say using namespace std, but remember when we include this calculator header file here in our int main, we already are using namespace std. So to avoid any clashes there, I usually leave this out of the header file and I do it the long way and just use my std : on any functions that depend on that namespace. So back in our main code, let us run our program. All right, let's see. This is not a member. Cout undeclared end line. Okay. Let's see here. Save. All right, so what is this saying? Okay. Oh, silly me. So even though we're not using namespace std, we definitely have to include our IO stream to be able to use cout and endline. All right, so keep that in mind. You need IO stream. You need to include your IO stream header file. So now we should be in the clear. Let's run our program. And you see our program has now compiled, and here we see the value of num is equal to 15. So we have successfully overloaded our unary operator plus plus. So quickly, let's recap what we have done. So let's go back to our calculator file. So first, let's recap how we did our function overloading. So first, we defined two sets of functions, and we called our function sum. So the name of our function in both cases is sum. So we're overloading that function. The first function has a return type of int, and it accepts two parameters of type int, and it returns the sum of those integers. The second function, sum, has the same function name, but in this case it has a return type of double, and then it accepts three parameters which are all double, and then it returns the sum of each one of those. So back in our main file, we created a calculator object here. All right, so our calculator object, and once we instantiated this object, we then simply did a print statement. So let us run this again. Let's uncomment it. So Control K, then U. Control K, U. There we go. And here, what we're now doing is simply printing. Sorry about that. The sum of these two numbers. So first we're calling our object that we instantiated here, and we are saying object.sum, and then first we're passing in two integers. So the program is smart enough to know, because you have told it to do so, that if you pass in two parameters, it will call the function that accepts two parameters. And if you pass in three parameters of type double, it also knows that it should simply work on those three numbers that are of type double. So the program is smart enough to choose which function to use when it is being compiled. So once we run this, we saw the value that we got. And just to recap, let me comment this out and run it again. And you'll see here the sum of the numbers. And if we pass in an integer, it will also accept it. So a double will accept either a double or integer, but not so for our function that accepts int. If we try to add that, it's simply going to leave off that integer value, or not that integer value, that decimal value. Okay, so that was our example that had to do with function overloading. So now let's comment this back out. So secondly, we declared a basic data member. So this is just a data member. We're just holding a value in our member. Then what we did in our constructor was, what we did here, we simply called our constructor, and then we instantiated our data member num with a value of 10, and that's pretty much all we did in our constructor. Right? So here below that, we have defined a function that overloads our operator. So plus plus is a unary operator, okay, and it increments by 1. So in this case, we're redefining that function, or that unary operator, or overloading it. So the return type will be void. Then we need to define that we're working on an operator, and then the operator we're working on is the plus plus operator, and we are redefining it within the function body here to say that we want to now increment by 5 instead of incrementing by 1. And my comment here is wrong, so let me change this to num plus 5. All right, and then our print num function is simply printing out the value of num, which is our data member, after it has gone through the process of being, called. So back in our main file, we have instantiated our object here, which is our second object. And then in this line, let me uncomment this. What is happening here is that we are calling our overloaded operator. So this plus plus here that we have defined is actually our void operator plus plus that we defined in our header file. And we are working on our calculator object. So we put that here. And then we're simply calling cal.printNum, which is a function that we defined in our header file. So once we run our program at this point, you see that the result is 15. And if we change this increment value to say 7, right, and we run it, of course the same thing will happen. Now we should have 17, right? So there we have it. That is compiletime polymorphism. Before we move on to runtime polymorphism, I want to demonstrate one more example of compile time, and this time I am going to use a binary or arithmetic operator. And what I am going to do is add two calculator objects to each other. So first, let us set that function up. So we're still on operator overloading. So now we are going to do a binary operator. And we are going to add two calculator objects. So let us, in order to do this, let us set up our calculator constructor. Let us set up to accept, let's declare an integer, and let's just call it n. And inside our function body, let's just say num is equal to n. We could also specify right here and say num n. So whichever way you decide to do it, both ways are fine. I'm just going to do it this way. So what we're going to do now is define our function. So let's say void, and let's say operator, and the operator is plus. And now we're going to pass in a parameter. So our parameter will actually be our calculator object. So we just type calculator because that's what our function will accept. And let us give this. So we're not going to do member functions. Let's just do the definition right here in the class as well. So inside this class, we are going to say int, let's give it another number. Let's say m will be equal to our calculator object dot num plus x, or cal rather. And we have an error here. Oh, sorry, this should be num. All right, so just to quickly explain what this is doing, we're defining, we're overloading this operator, and what we're doing is overloading the plus or the add operand, and we are simply passing in our calculator object here. So this is the name of our class, and the name of the object is cal. And inside this function, we're just simply defining another variable called m, and m will be equal to our object dot num, which will be our data member, plus num. So whatever the instance whatever we instantiate our object with, that number will also be added to what is passed in to this function. All right, so let us cancel that. And I believe that is all we need. So first, let me put a cout statement. So let's do std cout, and let's just say the result of adding the two objects is equal to, and in this case it would be equal to m, because m is what is storing the value when we add our two objects. So let's go to our int main, and now these, the reason we're seeing an error message under these is because we have now defined a constructor that takes this parameter. So if you remember in one of our previous videos, if you want to get rid of this error message, all you have to do is define a default constructor. So let's just say calculator, and let's just leave it empty. So this is our default. So now this is overloading our constructor. So now we can either decide to pass in a variable upon instantiation or not. So I'm going to leave these two as is, and I'm going to define a third object, and let's call this one call obj, and we're going to give this let's give it a value of 13. Sorry, it should be currently. And let's define another calculator object. So call obj2, and let's give this value also, let's give it a 20. All right, so we've defined our two calculator objects. Now we're going to add these two objects using our overloaded operator. So let me comment out this line. Okay, Control KC. And down here now we are going to say call obj plus call obj2, and this is going to add our two objects for us because we have overloaded our plus binary operator. Okay, so let's run this, and we get the result of adding the two objects is 33. So that's correct. 13 plus 20 is indeed 33. The relationship between abstract classes and virtual functions is really that an abstract class is a class which contains at least one virtual function in it. And abstract classes are used to provide what is known as an interface for its derived classes. These derived classes must provide a definition to the virtual function, and if they don't, those derived or child classes will become abstract classes themselves. These virtual functions are declared using the virtual keyword, and the keyword virtual actually precedes the normal declaration of a function. Virtual functions are usually accessed through object pointers, and when the function is made virtual, C++ determines which function is to be invoked at the runtime. And this is based on the type of the object that the base class pointer is pointing at. And of course, they are mainly used to achieve runtime polymorphism. So we've looked at compiletime polymorphism using function overloading, but now it's time to take a look at runtime polymorphism and a term known as function overriding. So this enables you to provide a specific implementation of a function in a child class, which of course is already provided by its base class. So let's take a look so we can understand this a bit better. So I'm going to do a new example. So let's create a new class. Call this class animal. So to demonstrate, let me define a quick public function, and I'm going to define a function called eat, and I'm just going to print std_cout. So in our animal class, I'm just going to define a function called eat, and it's going to just print eating. And remember, we need to include our IO stream. So we have our first class animal and one function inside that class. Now we're going to define a child class, and let's call it cow. And we're going to inherit from our animal class. So let's say public animal, and let's define a public access specifier, and we are going to now redefine or override our eat function, and our eat function is going to print eating grass. So that's really a simple way to demonstrate function overriding, and what will happen here is runtime polymorphism will take place once we create an object from our cow class and call the eat function. All right, so let us do that. And let's say cow. And we have to include our animal class. So now let us call c.eat. And of course, we expect our program to print this eat function. So if we had just inherited from animal and did not redefine or override the eat function, and we called c.eat, it would definitely print this function here, or call this function and print eating. But now that we have defined a child class called cow, and we have created an object from cow, and we are calling eat, runtime polymorphism will occur, and it should print eating grass. So let's run our program. And we see eating grass. All right, so just to show you that if we comment out this function definition, let's do a Control-C. And if we go back and run our program, we should, right, so we simply get eating. So now it is calling the parent class version of eat. Okay, so that in a nutshell is really all there is to runtime polymorphism and function overriding. In keeping with our animal class, let us now define a true virtual function in our animal class, and then let us override it in our child class. So let's go back now to animal.h, and remember, the virtual keyword precedes the function declaration or definition. Let's spell it correctly, virtual. So let's define a function called make sound. And to have a true virtual function, it will not have a function body. So let's make a comment here. This is a pure virtual function. Oh gosh, my spelling is so off right now. Function. And this is because there is no function body. So we're just going to set it equal to 0. All right, so now in our cow class, we are going to give a definition, because maybe it is that we do not know what sound an animal makes, right? So animal is just a generic class. But we do know that a cow has a particular sound. It makes the moo sound, right? And same thing for a dog barks, a cat purrs, etc. So in our cow class, we are going to override our make sound function and give it a body. And we're going to say, we're going to print moo. Right, so that's it. We are overriding the make sound function, and we're making our cow make the sound moo. So in our main function now, we've already created our object, so we can do a call and say c dot make sound, and when we run our program, of course we get the sound that our cow makes. So I would say try this one for yourselves. Create a class called dog and have it inherit from animal, and you can override both these functions, right? So you can have a dog is eating what a dog eats, and you can do override make sound and make the sound that a dog makes. All right, so try that one out for yourselves.